Hello everyone. Today we will start chapter number 5, Introduction to Euclid's Geometry of class 9th standard. So in Euclid's geometry there are two terms, Euclid and geometry. So what is Euclid? Euclid was a Greek mathematician. Okay, he worked in the field of mathematics and especially in the field of geometry. So he is also known as the father of geometry. Now second term is geometry. Geometry is the branch of mathematics and this word geometry comes from the Greek word geo and metre. Geo means earth and metre means to measure. So there was a need to measure the earth, or we can say land, so geometry is originated. Euclid assumed certain properties which were not to be proved. These properties or assumptions were universal truths. So he divided these assumptions into two types, axioms and postulates. So Euclid gave 7 axioms and 5 postulates. Now let's see what are the axioms and postulates. Axioms are the assumptions used throughout the mathematics. That means these are the properties which we are using in all the branches of the mathematics. And postulates, these are the assumptions which are used specifically in geometry. Okay, so there is a difference between axioms and postulates. Both are the assumptions, but axioms we can use throughout the mathematics and postulates we can use only for geometry. So Euclid gave 7 axioms. Now one by one we will discuss all the 7 axioms. First axiom says that things which are equal to the same thing are equal to one another. Now let's discuss with one example. If I will say that A is equals to B, okay, and I will say that C is also equals to B. Now A is also equals to B and C is also equals to B. That means A is also equals to C. So this is our first axiom and it is nothing new. We have already done this concept that if A is equals to B and B is equals to C, it implies A is equals to C also. So this is our first axiom. The second axiom says that if equals are added to equals, the wholes are equal. Now let's take one example. Suppose A is equals to B. Okay, now these are the equals. Now in these equals, if I will add 1 to both the sides, so A plus 1 will be equals to B plus 1. So if equals are added to the equals, the wholes are equal. Whole means the sum which we are getting A plus 1 and here we are getting B plus 1, both will be equal. Now let's see the third axiom. Third axiom says if equals are subtracted from equals, the remainders are equal. That's the same as B. But in the second axiom, we are adding equals and in third axiom, we are subtracting equals. So if we have A equals to B and if I will subtract, suppose 2 from A and 2 from B, then the remainder, that is A minus 2 and here remainder B minus 2, both will be equal. So this is our third axiom. Fourth axiom says things which coincide with one another are equal to one another. So suppose we have a square of side 1 centimeter and we have another square of same side 1 centimeter. If I will keep this square over this square, so it will exactly overlap because for both the square side is 1 centimeter. So when it will exactly overlap, that means it will coincide. Both the squares will coincide. So we can say that both the squares are equal. Okay. Same way, suppose we have a circle of radius 1 centimeter or 2 centimeter. We have another circle of radius 2 centimeter. If I will keep this circle over this circle, both will exactly overlap, or we can say both will coincide. That means both the circles are equal. Fifth axiom says that the whole is greater than the part. So this we already know. Suppose we have a biscuit. Okay, this is a rectangular piece of biscuit. So this is a whole. Now from this biscuit, suppose I will make 4 parts and if I will consider this part only, So this part is 1 by 4. So 1 by 4 is less than whole. So whole is always greater than the part. Sixth axiom says that the things which are double of the same thing are equals to one another. For example, if I will say we have a number 5 and here also we have a number 5. So these are the same things. Now we want to find out the double of this. So double of this will be equals to 10 and double of this again will be equals to 10. So the doubles of these sames will also be equal. So things which are double of the same thing, 5 and 5, double is 10 and 10. So these two are also equals to one another. Now, seven axiom says that the things which are halves of the same things are equals to one another. Now, sixth axiom and seventh axioms are same only. In sixth axiom, they are saying double of the same thing, and in seventh axiom, they are saying half of the same thing. So, if I will consider, let the numbers are 6. One number is 6, and the equal number is again 6. If I will do half of this, I will get 3. If I will do half of this, again I will get 3. That means halves of the same numbers are also equals to one another. Now let's discuss the postulates. Euclid gave 5 postulates. So we will discuss all the 5 postulates one by one. First postulate says that a straight line may be drawn from any one point to any other point. So for example, suppose we have this point A and if we will draw one straight line from this point, so it will pass through another point B. Okay, so a straight line may be drawn from one point to any other point. Suppose point A is here and point C is here. So we can draw a straight line from point A to point C. So this is our first postulate. Now from this postulate we have derived one axiom which says that given two distinct points, there is a unique line that passes through them. For example, suppose we have 2 points P and Q. Now we want to draw a line which passes through both the points. So I will draw a line like this, and this is a straight line which passes through both the points. Okay, now if I will try to draw the line like this. So this line passes through the point P, but it is not passing through the point Q. Same way, if I will try to draw like this, so this line is passing through point P, but it is not passing through point Q. At point Q, if I will draw the line like this, so this line is passing through point Q, but it is not passing through point P. So from this we can see that if the two distinct points are given, and if we want to draw a line joining these 2 points, it will be a unique line. Okay, we can draw only one line. So this is our axiom. Given 2 distinct points, there is a unique line that passes through them. The second postulate says that a terminating line can be produced indefinitely. Okay, terminating line means suppose we have this line A and B. Terminating means it has 2 endpoints. Now from this endpoint B, if I will extend the line, so I can extend it indefinitely. Even from point A in this direction, if I want to extend the line, I can extend it indefinitely. So a terminating line can be produced indefinitely. This is our second postulate. Now the third postulate says that a circle can be drawn with any center and any radius. Now see, if I will tell you to draw a circle, what you will do? You will take the center and then you will consider some radius, suppose 1 centimeter, and then you will draw the circle. So the circle can be drawn with any center and any radius. Same way, some students will take the center here and then they will take the radius, suppose 1.5 centimeter, and they will draw the circle. So circle can be drawn with any center and any radius. Fourth postulate says that all right angles are equal to one another. So for example, if I will draw one right angle like this is A, B and C. Right angle means 90-degree angle. And if I will draw another right angle, P, Q, R, again 90 degree. So right angles are always equals to one another. Now, fifth postulate, it is very important. It says that if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of the angles is less than two right angles. Now let's try to understand this with example, with figure. So here it says if a straight line falling on two straight lines. So this is a straight line which is falling on these two straight lines. Now this line is making interior angles on the, okay, so this is the interior angle, suppose angle number 1, this is the interior angle 2, this is also interior angle 3, and this is interior angle 4. Now it is saying that if the interior angles on the same side of it taken together less than two right angles. So if I will say angle 1 and angle 2 are on the same side, so we will take angle 1 plus angle 2. Now on the right hand side we have angle 3 and angle 4. So taken together angle 3 plus angle 4. Now the sum of these two is less than two right angles. So two right angles means 180 degree. Now we have to see from the figure the sum of angle 1 plus angle 2 is less than 180 degree, or sum of angle 3 and angle 4 is less than 180 degree. So here this sum is less than 180 degree. Then the two straight lines if produced indefinitely. Now if I will produce these two lines indefinitely. Now this I am producing till here, and this line I am producing till here. So it is written that they will meet on that side on which the sum of the angle is less than two right angles. So they will meet here. Why they are meeting here? Suppose this point is P, because at this side sum of these two angle is less than 180 degree. Now if you will try to extend the lines in this direction and this line also in this direction, they will never meet because here sum of the angles is more than 180 degree. So this is our fifth postulate.